Token based. Yep.
We're using a framework called Auth.
No, it's not a framework. It's an idea.
An idea? Okay.
Yes, like object-oriented programming, it's not a framework. It's just an idea.
Okay.
Not even a protocol. It's an idea.
Okay. So what app are we actually using for the authentication?
JWTs.
JWTs.
Yep. Yep. JavaScript web tokens.
Okay.
It's a modern approach to token-based authentication. That's what we'll be creating. That's what we'll be validating, and that's what we'll be authorizing, and that's what we'll be passing back in our request back and forth.
And for that, we need a controller.
Yep, because we need a new controller to actually create the tokens for us, to actually create the JWTs.
And we have to add that as a service. Or it's just a plain old.
It's just a controller for right now.
Okay, but there's no additional libraries that we have to install.
All those come with the templates. So if we look at the services that we did have to register, we had to say, hey, we're using authentication. We're using JWTs. Here's all of our configurations for it.
So those, when you say services, are they additional libraries, or what do we define as services? To me, I look at that and I go, okay, those are additional DLLs or additional libraries that you can take advantage of.
They are at a high level. It's things that aren't built in. It's things that are parallel to a web server that we still need. So like a web server is just at its core something that listens on a port and returns something. That's like the simplest web server in the world, right? But in order to make that useful, we need to add certain things to it. We need to add MVC to it. We need to add cores to it. We need to add authentication. We need to add database access to it. So things that those web servers need to function, to operate, that are parallel to it, but aren't part of the core web server stuff.
And those additional things come in the form of
Packages, libraries, DLLs, et cetera, et cetera. So we're saying, hey, our application is using JWTs, and here's how we're gonna bolt on how to configure them and how to create them.
so the security keys, say symmetric security keys, which are basically what the 1024. I'm trying to understand at a high level.
At a high level, it is taking this and it's running some encryption stuff on it. That's all we need to know right now. I actually don't know the details of it, but I'd like to find out.
I'm just saying, Paul said, this is a secure thing that
Mm-hmm.
that wasn't so secure because of 512, something 512.
Yeah, this is not something that we care about today. But what V is talking about is that there is always a size of the hash of what we create. And typically, we rely on the size of the hash to be so big that it's impossible to guess because it just takes forever. But as computers get faster and better, they can make more guesses per second, so that time to guess shrinks. And I think last year we just hit a milestone where 256 was too small, and we had to bump up to 512. Or 512 was too small, we had to bump up to 1024, one of those two. Um,
512 was that's a long math that it was
mm-hmm, yeah. Huh? Reasonable. Actually, it wasn't milliseconds, but it went from like decades to like, yeah, like something that someone potentially could try to break. Yeah. Um, so we configured it. A lot of stuff going on here. It's okay if we don't know 100% of what's going on here. The other thing we'd have to add is our use authentication to the pipeline. So remember this configure. This is building up our HTTP pipeline. So the order matters here. Thank you. Thank you. Not anymore. So we're building up our pipeline here. We're going, hey, whenever our application runs, the first thing that a request is going to hit is env is development. It's going to come in here. Then it's going to say, hey, redirect me to HTTPS. Then it's going to come back. It's going to go through our authentication wall to check for the authentication. And then the request is actually going to get to our controllers. So we've added it into our pipeline saying, hey, when a request comes in, check to make sure that it's authenticated.
So that is in order?
Yep, order does matter here.
What does
Cores would go right here. Yep. This is where I would put it. Realistically, you could probably put it below it as well. It just has to be above use MVC. This should always be last. But I would put it before authentication. We'll come back and add that in about an hour. So we've established that, hey, our application uses some security measures. Come over here to our values controller. We've said, hey, this route is only for authorized users, and that's it. So I have to log in to actually see something. So if I try to go there, let me run this real fast.
Those tags, those are just basically flags, right?
Yep. Yep, that's a good way to look at it. We're just looking, hey, it's because remember those are attributes that modify the next thing, whatever's after it. Just like we have our from query or from URL for parameters, we have our route controllers. Our controller's not really working yet. Somebody needs to get their brakes changed. Let's get this running. There we go. So yeah, so just like the API controller can modifies the values controller, the gets modify the next action, the authorized modifies the next function that it's on. So our get all is behind the wall, but our get one is not. If we wanted to, we could actually move this up here, and this says, hey, all my methods inside this controller are now only for authorized users.
So if you move that above the API controller, does it make it better, worse, or?
No, it's the same. Yeah, a lot of developers like to keep these in some sort of order. I just kind of stick the defaults on top and then kind of populating below. Some like alphabetical, some like how big it is. They could get long in other places. We're going to get to a time where we can actually set requirements on our models with attributes. Those might get long, but no more than 6. No more than half a dozen. If there is more than half a dozen, you probably want to rethink what you're doing. So that's kind of where we are, right? We have something that's behind a wall that we cannot get to. If I send my request, I should get a 401 back. .401. So now I'm unauthorized. I cannot similar to 403. This is saying, hey, this route requires authentication. You are not authorized to do anything. So that led us to say, hey, we need to create an endpoint that we can post information to, username and password, and actually get a token back. Then we can take this token, send it with this request, and actually get the information. Yep. How are we feeling so far? High level, feeling good? Yeah. Oh yeah, we're still at a high level. Authentication's a deep field. So we started to build out our token endpoint. Now I took the liberties and added a couple things here that we'll look at. Um, the first one that I added is this right here, is our token controller constructor. So this should look kind of familiar. We have a constructor that takes a parameter. So what this is doing, this is looking at the web framework and going, hey, web framework, whenever you new me up, I need to know the configuration of the site. So this is the web framework, ASP.NET, using dependency injection to inject in the current configuration for the site.
Why do you not have to get
Because this is just now a private variable. It's not a private property.
okay, so when we were doing the database, the context,
Mm-hmm.
injecting that, we used get set because it's public?
No, because it was a property. It's just a different way to do it.
Is this similar to Civ at all?
No. No.
So close.
Almost. Kind of. It,
Maybe abstract way.
in the super abstract ways that we're writing programs. Yeah. So this is just saying that we're like, hey, we need the configuration of the entire web server to run. And we need that because now we have two new functions here. We have two new methods here. One is called build token and the other one is called authenticate. So this authenticate is relatively simple for right now. It's doing nothing too crazy. It's just saying, hey, whatever you pass in, if the username is this and the password is this, return me a user, else return nothing. For now, we're going to make this simple. Eventually, probably in about an hour or so, we're going to move this to a database. So instead of a hard-coded value, it's going to be a database call.
So at some point, right,
Mhm.
designing work in the open,
Yeah.
do we hash the secret password?
Mm-hmm. Oh yeah. Oh yeah.
Okay.
Yeah. We're going to get there. So that's all that's doing. So that's our magic gatekeeper right now.
And the other question, you have ID equals 1.
Yep.
Why are you setting is that
Of the user.
of the user?
Mm-hmm.
That is different from the primary key.
Nope. That would be the primary key.
But so if once we move it to the database, would we have that?
Nope.
Okay.
Yeah. This would be replaced with a select or a where or a first or default kind of thing. So that's all that's doing. It's a lot of hand waving, a lot of smoke and mirrors, but we're just saying here's something that says yes, this person's valid, or yes, it's not. The other function that we have here, this is where we're actually going to build the token. So there's a whole bunch of stuff going on here.
Did this come from the template, or is this something we have to do?
This is something you have to add, but it becomes a very copy and paste job. It becomes a very copy and paste job. And truthfully, this isn't something that will actually end up in your final apps. Shouldn't, at least. Even if you're using token-based stuff. Because we're going to explore next week a service called Auth0 that takes all this complexity and manages it for you. So you do not have to worry about it. This is just kind of peeking under the hood and seeing what it's doing.
Did you build this yesterday? Did you build this one yesterday?
I've been playing around with it recently, yeah. So let's look at what we're doing here. We have our key, we have our creds. So that's what's actually creating that digital signature based on that configuration value. Remember how we added the key value inside of our app JSON yesterday? So it's looking at that secret key, that very long private key, and going, hey, take this and create for me a digital signature.
I'm imagine you have available to you some other algorithm, well, security algorithm besides SSH256.
Yeah. You could change that. Um, so now we have our signature. Claims is another part of JWT. Inside of a JWT, one of its strong features is that you can use it to verify that the data inside of it is correct and valid and has not been tampered with. Right? So we're saying, so what the claims are doing, the claims is this idea is that whenever we're creating this token, we're making claims that this user is who we say we are, who we say it is. So right now, we're just making a unique ID for it. Saying, hey, we're making a unique ID for this claim. We're going to add a couple things to it, like the user ID, the user email, kind of some things to work with it. But for right now, we're just saying, hey, this JWT, we're creating it, and that this user is valid.
So we create this token.
Yep.
Do we have to store it anywhere to keep track of it to see, because we're managing, I imagine that we're managing multiple tokens because multiple users are logging in.
We do not need to actually store it. That's where this is really kind of powerful. Is that we know because whenever we go to use it later, whenever we go to consume it, we check the digital signature of it. And if that digital signature doesn't line up, then it's an invalid token.
So we know what the algorithm is. So
Yep.
Magic. Okay.
Yep.
Okay. So, but is a token so stored on the client side?
Correct.
Okay.
Yeah. So in 40 minutes, when we create a React app that uses this endpoint, we'll be storing that token in local storage. And then just passing that back and forth with every single request. What? Local storage? it never goes away. And actually, better use would probably be session storage, because local storage is persistent across times you hit the page, but session storage is only as long as you're on that domain. It gets cleared after you leave.
And that can be done with this.
Mm-hmm. So we're creating our token on line 45. We're saying, hey, who's signing it? Who is signing it? We're saying what claims we have, and then here's the signature. So we're putting all that into a really long token and returning it. How are we feeling? So now we need to use this somehow, right? We have all of our tools inside of our belt. So what does this actually look like? So up here inside of our token endpoint, we no longer want to return OK. We need to get the current user by authenticating the incoming data. Because remember, this login model, just to refresh our memories, is just a username and password. So we're saying, hey, if user does not equal null, user exists. So if the user exists, we want to create the token and return the token. So if our token equals build token with the user, and then return an OK with the token.
Could you say if user? Just out of curiosity.
Nope. That's a JavaScript thing. Yeah, that's taking advantage of the truthy and falsiness of JavaScript. That's not in C#. So if it's wrong, if it doesn't exist, what do we want to return?
Well,
Yeah, we could say like user account, like bad credentials, user doesn't exist, or something along those lines. So we'll still return an OK, but a new object message user does or bad credentials.
What does OK do again?
OK returns a 200 response saying, yes, I got your response and it was handled successfully. But if you pass it an object of any type, that will be in the body of the response.
Gotcha.
So here in our first OK, the body is going to be a JSON object that has one key called token. In our second OK, the body is going to be a JSON object with a key called message.
You can get that on the client side.
Yep. So let's head over to our client over here in Postman. Let's head to can we hide that? So inside of this, we want to do now post to our API token with our username and password. I'm going to send it, and we're going to get a server error. What? That's super interesting. Well, so it's giving me that our key size is wrong.
Key size.
Yeah. And it is 10:47. So let's take a 13-minute break. Um, the reason why this is throwing me off because I literally have it working on this screen, and in this project it's not working. So let's take a 13-minute break. Come back at 11 o'clock, and we'll continue.
So what's it's a comma.
It's going to be something crazy ridiculous.